chapter, besides review for the test, is convert equations from polar to rectangular and rectangular to polar. But it's the same process as what we did yesterday with points. You really got to know three things. You need to know that x is equal to r cosine theta. You need to know that y is equal to r sine of theta. And you need to know that x squared plus y squared equals r squared. If you know those three things, you can convert from one to the other. So if it says convert to a polar equation, that means all the x's and y's have to change to r's and thetas. That's how you know when you're done. So we're going to start with something not so bad. If x equals 4, can we replace x with something that has r's and thetas in it? Yes, because we know x equals r cosine theta. So we could say this is the same as saying r cosine theta equals 4. Just like in a rectangular equation, usually we solve for y if we can. In these equations, we usually solve for r if we can. And actually on the graphing calculators, you can change them to polar mode and you can graph, and you have to have like r equals. So I want you to practice on these. Once you get the x's changed, solve for r. So if I was going to solve for r, do you agree I could just divide this cosine over? Can I do anything else to make that look better? Cosine's on the bottom. Could I bring it up and make it... Oh, over. Oh. Excellent. 1 over cosine is the same as secant, right? So really, this is like a better answer, and so definitely like odd questions, you want to check your answers, and you kind of just get in the habit of trying to solve for r and simplify what you can. Okay, let's do some more. I feel like I should have printed these notes out because there's just a whole lot of white space on here. But then you guys never have paper. It's past what? Worth learning. Yeah, because we all know it. I'm recording right now. Nick will watch it. Jake will watch it.
No, you shouldn't host it. So if you're not going to school, you're going to have a senior skip day. You don't deserve.
I have them in 5th hour, so I can just play the video for them in 5th hour. Can we plug in for x and y?
Yeah.
Yeah, x equals r cosine theta, y equals r sine theta. So we're just going to replace. Every time you see an x, you need to know that's the same as r cosine theta. Y is r sine theta. Oh dear. Hello? He is absent, sorry. Bye. I'm going to take my attendance. Get in trouble. No, Nick Chambers. Someone else must not mark him absent. Y equals r sine theta. And then again, we want to kind of clean it up a little bit. So if we want to kind of get r by itself, r times r equals r squared. Could I divide cosine and sine over to the other side?
Wait, wasn't there an equation?
4.
That was like cosine, sine plus cosine.
Sine squared plus cosine squared. But we don't have sine squared or cosine squared, right? We don't. I want you to get in the habit of knowing if you have a trig function in the bottom of your fraction, you can always make it simpler by bringing it up as its reciprocal function, right? So I think the better answer here is 16 secant theta cosecant theta. I just break r squared. Oh, right? It's all multiplication, so you can break up multiplication, do it in any order that you want. Commute it to the 2. And you might say, well, we should take the square root of r because we should get r by itself. And you're right. If you're going to type in the calculator, So I'm going to leave it like this. If you took the square root, I would mark it wrong. So if it's x's and y's, it's not that bad to change it to r's and thetas, except maybe the next one.
Yeah.
This one looks scary, right?
X squared.
You could sub in right now. X equals r cosine theta, y equals r sine theta, and then FOIL it out. But at some point, you're going to have to FOIL that out. So for me, my advice to you is let's FOIL it out first with x's and y's before we plug in r's and thetas and make it look uglier. So remember to FOIL this out. There's like 2 of them, right? So you have to do the 4 things. Hopefully not that bad to do. That you have x squared, and then 3x and 3x makes 6x, and then 3 times 3 is 9, and then y squared plus 6y plus 9. Agree with that? So if we subtract the 9s over, that's just going to cancel out that 18 over there. Can you agree with that? Minus 9, minus 18. And then I'd have x squared plus 6x plus y squared plus 6y equals 0. We could. Everywhere we see an x, plug r cosine theta. Everywhere we see a y, plug in r sine theta. But I see something else in here too. What's the third equation I told you that we could use today? X squared plus y squared equals r squared. So to save a little bit of work here, if you notice that we have an x squared and a y squared, we could just go ahead and say that's r squared. If you don't notice it, you'll get there eventually. You're just going to have a little bit more work to do. And I'm just going to replace that x. So I'm going to say 6 times r cosine theta plus 6 times r sine theta. And then I think the hard part about these is knowing what to do. Like, where do I go from here? Should I factor an r out? Should I divide an r out? Should I move the sines and cosines over? I kind of treated it like the last one where we had the r squared equals. So I moved these 2 over. So I wrote that as like minus 6r cosine theta minus 6r sine theta. And then if I looked in their answer book for this problem, they had r by, they just had r equals because they just divided by r. So this all has an r in it, which you could have done on this line too. So they just divided everything by r and said r equals negative 6 cosine theta minus 6 sine theta. And on a test, if it was open-ended and you didn't do that last step, it would be okay, I think. So that's where checking odd answers in the back is kind of nice because you can see how they leave it, kind of get in the habit of doing that. What kind of equation would this be if we graphed this? What conic section would that be? There's no fractions. A circle. It's a circle. Because there's no fractions, that means that the major axes are the same. It's addition, not subtraction. Okay, what about the other way? The other way is maybe, I think, a little bit harder because sometimes you have to do a little work to get there. Same rules apply, except for going the other way. So now I want all the r's and thetas to change to x's and y's. So you're not done until you only have x's and y's and numbers. You can't have any trig functions left, thetas or r's. Same rules. X equals r cosine theta, y equals r sine theta, and r squared equals x squared plus y squared. The harder part about going this way is you have to put things in this equation sometimes to match up, right? What does just cosine equal? Nothing really. What does just r equal? Plus or minus the square root. Like, it's just going to get really ugly. So what you want to do is think about what can I do to both sides of this equation that would make it look like something I could sub in. So some people might say, well, let's square it, because if I square r, then I could do this, right? But if you square this side, you're going to have cosine squared, which still doesn't get us anywhere. So I always think about, if I see a cosine, wouldn't it be really nice if I had an r there right in front of it? So what if, instead of squaring both sides, what if I just multiplied both sides by r? Would that kind of change it to fit something that we want? And it would, because if we multiply both sides by r, which we're allowed to do, we would have r squared equals 2r cosine theta. And for the most part, they're not going to give you this so nicely, right? They're going to give you something before that you have to do a little bit of work for. But now it's just substituting. R squared equals x squared plus y squared. And r cosine theta equals 2x. I'm okay with you leaving it like this, but just to let you know, if you were going to put it in standard form, in the pre-cal book, they always work this out, and they say, well, we've talked about, for conic sections, if x squared and y are both squared, and the numbers in front of them are the same, you know that it's a circle, a hyperbola, an ellipse, or a parabola. It's a circle, so if you wanted to put that in standard form for the circle, you'd have to subtract that 2x over, and complete the square, and then you get the equation for a circle. So what would that be there? Plus 1, plus 1. So that would be x minus 1 squared plus y squared equals 1. I'm okay if you leave it like that. Since we have done conic sections, it's not that bad to actually work it out. It's kind of some good practice. In pre-cal, I told them on the test, if they had something like this and they worked it out to this, I'd give them an extra credit point. So we'll see how much it shows up. But that is something that kind of relates. Why do we do conic sections and polar coordinates together? Because we are talking about conic sections. All right, let's do a couple more. Secant. Secant is not one of the three equations I told you to know. So we have to use our thoughts about trig here. So anybody have any ideas of what we could do on this? Secant is the same as 1 over cosine. So could I say this? That's the same thing. And there's more than one way to do this, so you might think of something different. It'd be really great if I had r cosine theta, right? So could I get that cosine over on the other side? Right? Like if I just multiply cosine on both sides, I would have r cosine theta equals 4. And what does r cosine theta equal? X equals 4. I'm pretty sure that's the exact reverse of like our first problem that we did. Our first problem started with x equals 4 and ended with this. But it went the other way. I know, how about that? So sometimes you're going to multiply in something like an r. Sometimes you're just going to have to use some trig and move stuff over. How do you know what to do? Use the 3 rules. Try to get at r cosine theta, r sine theta, or x squared plus y squared. Is this the last one? We do the same thing we did on the last one. It doesn't quite work out the same, right? We would have that if we change that to cosine. So we can't replace that with x. Any ideas?
Multiply the cosine theta to the other side.
And then just like the first one, we could multiply an r to both sides. So I would have x squared plus y squared equals 3x. And again, I'm okay with you leaving that as your answer.
function. So it's called. Isn't it like 1 plus?
Sine of 2 theta equals 2 sine of theta cosine of theta. That's me, right? Who is it? So that was the hard part of it. Now we have to think about what we want to do in here. If we times by r, we can put an r with this sign, right? So can I times by r again? To fit an r in there. A lot of r's over there, right? So however you want to write it, we can write it as r to the 4th, or if it's easier, that's the same as r squared and r squared, right? The same as r to the 4th. And then we'd have our 2r sine of theta, r cosine of theta. So what's really great about having equations is you're allowed to multiply stuff in to make it fit what you need, as long as you know what you need. And x squared plus y squared equals r squared. So I could write that twice, or I think that's just the same as saying x squared plus y squared squared. Agree with that statement? This would not be a conic section that we know, right? Like, this would have like x to the 4th in it, and there's a 2yx, and this would be, I don't even know what shape this would be. Kind of makes me want me to graph on the graph calculator while you do homework. Do it. Let me tell you what to do first. Because I'm the meanest teacher in the world.
Can we watch a music video? Because
Yeah, I've never.
all I'm saying is in English, we watched the Blank Space music video, and T-Swift gets real crazy.
Why did you watch that?
Because we watched a music video while I was sleeping. And she like stabs a cake. It is scared.
Oh, see her.
Some of these say graph. You don't have to graph, okay? Oh, there's some good ones in here.
You already have 4 albums.
They're not that bad to do.
We already have 4.
Many guys think there's no school left, but
There's no seniors left.
yeah, how about that?
We're slowly dying off.
Don't do that. And it's on the same page as